Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson, Introducing Derivatives. In the last lesson, we learned to sketch a curved graph. Today, we will learn the graphical definition of a derivative. We will begin by defining the secant and tangent lines. A line which intersects a continuous graph in exactly 2 points like this is called a secant line. A line which touches a graph in exactly 1 point is called a tangent line at that point. The intersection point is called the point of tangency. The slope of the graph of a function at a point P is the slope of the tangent line at point P. Let us consider the graph of y equals x squared. First, we will find the slope of the secant line passing through 1, 1 and 2, 4. The slope of the secant line is 4 minus 1 over 2 minus 1. This equals 3 over 1 or 3. This is the average rate of change of y on the interval 1, 2. In most cases, the average rate of change of a function on x1, x2, when x1 is less than x2 is the slope of the secant line passing through the 2 points. So, the average rate of change equals f of x2 minus f of x1 over x2 minus x1. Now, let us find the slope of the tangent line at 1, 1. We will let Q be another point on the graph of y equals x squared, such that the increase in the x coordinate in moving from P to Q is represented by the lowercase delta x. Then Q has coordinates 1 plus delta x, 1 plus delta x squared. As a result, the slope of the secant line is expressed by 1 plus delta x squared minus 1 over 1 plus delta x minus 1. This simplifies to 1 plus 2 delta x plus delta x squared minus 1 over delta x. When we divide the numerator by the denominator, we find the slope of the secant line to be 2 plus delta x. Students, notice that the tangent line is the limit of the secant lines through the coordinates 1 plus delta x, 1 plus delta x squared, as delta x approaches 0. Therefore, the slope of the tangent line at 1, 1 is the limit of 2 plus delta x as delta x approaches 0, which equals 2. Students, in general, the instantaneous rate of change of f of x at x naught, f of x naught, is represented by the slope of the tangent line at x naught, f of x naught. Now, let us learn about the functional notation in order to find the slope of a function at a given point. The gradient of the secant line is expressed by f of x plus h minus f of x over x plus h minus x. This can be simplified to f of x plus h minus f of x over h. Using the same method as in delta notation, we can express the gradient of the tangent line at P as the limit of f of x plus h minus f of x over h as h approaches 0. Let us apply this idea in our first activity of the lesson. Let f of x equal x squared plus 2x plus 2. Given this function, find the limit of f of 2 plus h minus f of 2 over h as h approaches 0. You may get started now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. Did you find the gradient of the tangent line? Here is the gradient. When we substitute in our function, this is the result. The limit of 2 plus h squared plus 2 times 2 plus 2h plus 2 minus 2 squared plus 2 times 2 plus 2 over h as h approaches 0. This simplifies to the limit of h squared plus 6h over h as h approaches 0. Dividing the numerator by the denominator, we find that the limit of h plus 6 as h approaches 0 equals 6. This is the gradient of the tangent line. Now, let us turn our attention to the limit of the quotient difference. Let f of x be a function defined in a neighborhood of a point x naught. The ratio f of x minus f of x naught over x minus x naught is called the quotient difference of f at x equals x naught. If h equals x minus x naught, then x equals x naught plus h. The quotient difference can also be given by the following formula. F at x naught plus h minus f at x naught all divided by h. For our second activity, please find the quotient difference of this function when x naught equals 4.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. We will find the quotient difference for A. F of x minus f of 4 over x minus 4 equals x plus 1 minus 5 over x minus 4. This simplifies to x minus 4 over x minus 4, which equals 1. X must be different from 4. If the limit of the quotient difference as x approaches x naught exists, then it is said to be the difference quotient of f of x at x plus 1 at any point x naught belonging to the set of real numbers is 1. We will find the quotient difference for B. Sine of x naught plus h minus sine of x naught all over h is equal to sine x naught times cosine h plus cosine x naught times sine h minus sine x naught all over h is equal to sine pi over 3 times cosine h minus sine pi over 3 plus cosine pi over 3 times sine h all over h is equal to square root of 3 over 2 times cosine h minus 1 over h plus 1/2 times sine h over h. That brings us to the end of today's lesson. We have learned the graphical definition of a derivative and how to find the secant and tangent lines of a graph. Until next lesson. Thank you, teacher. Thank you, students.